Welcome to today's lesson. I am Siamasaka Kiriandens. So I'm going to actually go through a lesson using actually the convex lens or converging lens. So the convex lens is also known as the converging lens. So we are going to look at the characteristics of the image formed by a convex lens. So we go straight to the lesson. We are going to look at any object which is beyond 2f, beyond actually the focal point number 2, and we'll look at the characteristics of the image, how the image appear. And so if you have a convex lens, generally we want to see first of all how to draw actually the rays. And so we have the optic center here, we have the principal focus here, we have another 2f, that is the distance from the optical center to the focal point is the same as the distance from f1 to f2. Similarly, on the other side, we are going to have f and 2f. So generally, if you place an object, say, beyond 2f, the rays, you draw a parallel ray which should go straight up to the middle of the lens. And then it should diverge, it will be refracted through the principal focus. And then the other ray will come from the top of the object through the principal, through the optical center, and this one does not bend. Any ray of light that passes through the optical center does not bend. And where the two are going to meet, that's where actually the image is going to be. So we're going to have our image here, and we're going to have our object here. So we notice that from here, this is actually the scenario. When we place an object beyond 2f, we can actually see that the characteristics of the image, it is actually, the image is between f and 2f. So characteristics of the image. One, it is between the principal focus and 2f, as you can see from here. And then number 2, it is a real object, a real image. A real image is one which can actually be cast on the screen. So it is real. And number 3, the image is actually smaller than the object in terms of height. If you can check from here, you notice that actually, if you look at this height here for the object and the height for the image, you notice that actually the image is actually diminished. So when it is small, we say actually it has diminished. Okay. Say that is actually diminished, meaning that the image is smaller than the object. And so this is how actually an object which is placed beyond 2F is actually produces an image with these characteristics. So really what you draw is you draw a ray of light up to the middle of the convex lens, which is actually parallel, and then it actually goes through the principal focus up to the end there. And then the other ray, it comes from the head of the object and it passes through the optical center straight. This one, it does not actually diverge. It is not refracted at all. It will go straight and then it intersects with the other ray. And where the two meet, actually, that is where the image is. You notice that where they are meeting here, where the two rays are meeting, that's the head. Similarly for the object, that's the head. At times, you can draw a ray passing through the principal focus here, and then it means that when it comes out from here to be parallel, to pass in that direction. So this is actually exactly how you can obtain the image of an object which is placed beyond 2F. Thank you.